we have equation of two variables here, and order 2, we try to find how many integer solutions are there, and the first thing you want to do is try to factor this equation. Let's do that. So rewrite it as 4xy minus 19x minus 93y equal to 0, and factor. Let's try here to split it. This has to be 19 over 4. This one would be 93. So the factor is 4x minus 93 and y minus 19 over 4. That's constant that you have to add on both sides. That is 493 times 19. Let's get rid of the fraction by multiplying 4 on both sides. What we get is 4x 93 and 4y 19 and equal 19 times 93. I'm going to factor that as 3 by 31. Okay, so you may think the number of positive factors is going to be 2 times 2 times 2, that's 8. So is the answer 8? Alright, notice that integer means could be positive or negative. Y could be negative. So then you say, okay, how about let's double that, right, for the negative numbers. But think about it, is that true? Let's say if you want to split, if 4y minus 19 equals 3 and 4x minus 93 equal, the remaining one is going to be 19 by 31, right? Would that be a solution? Because the way you count it would include that. But that, however, this one, y would equal 22 over 4, not an integer. So that's the whole thing. This does not work. Okay? So, in other words, this may not be correct. Now, how to solve this problem? Now, we need to consider mod 4. Okay? So, we're going to look at, there are two cases here. You have two numbers, and this integer we want to get. So case number 1, both factors are positive. Of course, then case number 2 would be both are negative. Okay, so in this case, when you write it down, the 4x minus 93 smaller than 0, and 4x minus 19 smaller than 0. Okay, so when they are positive, let's consider mod 4. Okay, so 4x minus 93 mod 4, then this is 92 is multiple of 4, so that's gonna be here. How about 4y minus 19? Only 19 matters, plus 20, you get 1. That's good. Now, how about these factors here? Let's consider all the prime factors here and 1. So this is the factor p, and that is p mod 4, right? Let's figure it out. So you could have 1, you could have 3, you could have 19, and you could have 31. In this case, mod would be 1, negative 1, negative 1, negative 1. Okay, so in order to have a integer solution, so you have to make sure that the second one, so 4y minus 19 must be congruent to 1. So in this case, could equal to what? What's the possible values here? Could be 1, or could be some pair of two numbers from here, right? So there's 3 such pairs. That is 3 by 19, 3 by 31, and 19 by 31. So corresponding this, we're going to have 4 solutions. Okay, so here we have 4 solutions. In the second case, we have both numbers are negative. So in this case, 93 minus 4x would be positive, so is 19 minus 4y. Now, similar, we consider mod 4. In the first case, 93 is congruent to 92 is a multiple of 4, so that's going to be 1 mod 4. And 19 minus 4y, that's going to be negative 1 mod 4. So we're going to use the similar analysis for the combination of factors here, right? So in this case, we're going to claim that 93 minus 4x would take the value of, over here, different combinations of it, right? So we need to get a 1 here. So the analysis would be similar to the previous results. Okay, so previous result is here. So this is going to be here. Okay, so in this case, we also have 4 different solutions for x, and that's for y. So in summary, so we have 2 cases, and in either cases, either this quantity 4y minus 19 or the other quantity takes 4 different values. So the total, we have 8 solutions for the original equation. Okay, so that's the correct answer. All right, thank you for your time.